I'd like to introduce you to JF Brandon. He was new to us in Berlin this year, and if I recall right, had quite a few visitors to your space there in Berlin. JF is going to talk about, by light alone, the next generation of fabricating 3D electronics at a mass manufactured scale. So with that, JF, I'm going to shut off my mic and my camera. I'll come back in a couple minutes before you're due to finish, just to let you know. But the floor is all yours.
Fantastic. Okay, so yes, I am JF Brandon. I am from founder of MAASS. I'm also a partner at a research company called Nectar. And we have an office in New Hampshire, where I am based, and another office in Arkansas. And I'm here to talk about multi-material 3D printing with a focus on electronics, and for our promise for going to mass manufacturing. Let's go to the next slide. So a little bit of myself and where my concept and ideas are coming from. I've been in 3D printing for about 15 years. I've been involved in printing concrete. That is a 3D printed concrete piece I'm next to. I've also been printing very small things. I was involved in Bot Factory for many, many years, where we were printing with inkjet circuitry and 3D circuitry. I've also been involved with, I started out at GrabCAD, which is a huge online community of 3D printing enthusiasts, and I was involved in 3D Shapes, a 3D search engine. So I've been involved in 3D printing in many different areas. And next slide. I sort of encountered quite a lot of sort of interest and challenges in the area of multi-material 3D printing. Specifically in trying to mix two materials together and trying to do it at scale. It's always been a problem, and it's a really interesting problem with a lot of benefits. Because if you think about it, the net benefit of printing with multiple materials is that you can essentially, you get more than what you have putting in. Your sum is greater than the parts. And when you apply it to something like electronics, you think about how all electronics are essentially multi-material objects. Being able to 3D print functional devices that have conductors, parts, components embedded within them have a huge benefit on industrial scale. Less costs of fabrication, less assembly, more functionality fundamentally. Next slide, please. So in order to essentially go towards a sort of ideal multi-material fabrication, I started from the beginning. I mean, I've been involved in 3D printed electronics for many years, but I wanted to start from a couple of years ago, 3 years ago, I wanted to start from essentially the beginning and look at what we had. There's hundreds of ways of doing additive fabrication, hundreds of different processes. I'm not kidding. It's just grown exponentially. So I went backwards and said, what would the ideal technology look like? And what would it need to do? And then I would essentially go through and select the kind of processes you want to use to fabricate electronics, to do multi-material printing. You want to have a process that's scalable, where it's cheaper to make more. You want a process that has high precision. Not all 3D printing technologies are precise. Some of them are terrible, but they can print fast. Embedded parts is important. I want to be able to print materials that have high purity and density, which is an issue for many different technologies. And I want to be able to use a process that has few limits on material choices. Next slide, please. So working that way, we kind of looked at all the different existing additive manufacturing processes to make our idealized technology. And what we looked at was those 5 areas. And we looked at, for example, material extrusion. We discarded like FDM. It's difficult to do the kind of precision you want. Yes, there are some technologies you can get very high precise prints with FDM, but it's slow. So it's not scalable. So it's not useful. Material jetting, which is what a lot of people think of with multi-material printing. I have done it. It has issues with throughput. I know there's some interesting inkjet systems, but they clog, and there's issues with materials and inks and so forth. I discarded that as well. Binder jetting, powder bed fusion. These have challenges on the mixing different polymers, even if you can print full metal. And they have good high throughputs, but you can't embed parts. And DDD is also incredible technologies, but it has other issues in terms of, resolution and so forth. The 2 I liked the most, and the ones we worked on, were Stereolithography, also listed here as that photopolymerization.